Welcome to part 2 of Competency 10. In this video, we will work with polygons and quadrilaterals. Listed here are, of course, your common polygons, which would be your triangle, quadrilateral, pentagon, hexagon. After that, yes, octagon, you may see some things about your regular polygons. But for our purposes right now, we really need to focus on the most common, which would be your triangles and your quadrilaterals. That means your rhombus, squares, rectangles, trapezoids, and kites. Number one, the bases of a trapezoid are 8 centimeters and 12 centimeters, and the height is h centimeters. Which equation can be used to represent A, the area of the trapezoid in square centimeters? Okay, this is just a basic situation of using the formula correctly. So look on your formula sheet, which you will be allowed to use during the test, and that is if you don't have it committed to memory. Of course, you can see the similarities of each one. They're all divided by 2, as they should be. They all have a numerator multiplied by h, which would be for the height. That's good. There's one key difference. The two values of the base, B1, B2, they should be added. Well, the only time that that's added is option A. Oh, here, let me write that so you actually can see. That's the only occasion when it's added correctly. So the other items are incorrect. Okay, now let's look at number 2. Okay, what is the value of the area and second base of the trapezoid below? They mean the bottom base. When I read that, I kind of laughed. I was like, are we playing baseball? But anyway, we can move on now. Okay, so obviously we have a situation where this trapezoid can be considered constructed from a square and a triangle. So the height is, well, let me just say that we obviously have a square situation. So these, we have parallel and a congruent, sides are all congruent in a square. So this is telling me that the height is 3 as well. And we have 3 here. Now our job is to find this one missing piece over here. So we have this one distance here. Let me highlight that. Ooh, we need a different color highlighter. This one little section here of the base. Well, if we look at the triangle that's been created, I see a hypotenuse of 5 and I see a leg of 3. Well, if you remember your primitive right triangles, this would be a 3, 4, 5. Now, how do we know it's a right triangle? That's another thing. You also have to be 100% sure that you're dealing with a right triangle. And we are. Because of the square, we have some situations where we have right angles. A square has all 4 angles are 90 degrees, and that guarantees this right triangle here. Guarantees that right angle on our triangle. So therefore, we know it's right triangle. So we have a 3, 4, 5 situation. Well, you can check that. So let's go to our calculator and use the 3 and the 5 that we already knew in order to see if 4 is correct. Okay, so say second under the radical, we would have 5 squared minus 3 squared, and that equals 4. So there you go. But that is alone is not what we need for that base, right? B2. So that would be this here. So that would be the 3 and the 4 added together to give us a nice 7. Well, probably you can already see what the value, I mean, which option we need. Okay, well, looks like it is C itself. So let's see here. 3 times 3 is 9. And we have 3 times 4 is 12 divided by 2 gives me 6. Well, I did all that in my head. Probably not the best thing to do. Okay, so let's look. I'm going to do it in pieces like I did and then as a trapezoid. And my values should match, okay? So what do I have? In parentheses, 3 times 3. Close your parentheses. Add that to, in a fraction, I have 3 times the 4. Now divide that by 2. So that's the area of the square plus the area of the triangle. Press enter. That is 15. Okay. And you see 9 plus 6 is 15. So that verifies C. But let's try it as the area of a trapezoid. And this is a right trapezoid. Okay. So let's say fraction, parentheses. B1 is 3, but we need to add that to the 7 that we found. Close your parentheses, and our height is 3. Then that's all divided by 2. Now we should get 15, and we do. So I would say C is verified. Okay. All right, let's go to number 3. Number 3, if the area of a trapezoid is 9, what is the height h of the trapezoid? Now you might be very tempted to write things down and solve. Let's not do that. I say we use our table function. So press table, clear everything out. Oops. Let's go back. We need to clear everything out. So I pushed enter accidentally, I think. So just clear it out and put in the formula. And let's say that h equals x for our purposes. Not sure why that's doing that. There we go. Okay. So put your fraction in and your parentheses. Well, we have the value of each base. So B1 plus B2, that's 3 plus 6. Now notice I didn't add them together. Just type them in the way they would be in the formula. So we need X here instead of H, okay, because that's what our calculator needs to use. Okay, now we go down and divide that all by 2. Okay, so we have our variable inputted for H. So now let's push enter. And we are going to ask for each of these options, A, B, C, D, and see what happens. Okay, so let's go down and then press our OK. Now remember, you have to delete out all the prior answers. Oops, I didn't delete out 40. Go up. Let's try 4. Is 4 it? Now, how do we know when we have it correct? It will have to equal 9. Okay, we're looking for 9. Okay, so let's push enter for our 4. That's not 9. So I'm going to say that's incorrect. Let's try 3. Nope. Oops, wrong one. We had 3. Okay, let's try 2. Ooh, two's it. 2 works. Nice. Okay, just for safety's sake, let's go up to the top, delete out to clear it so we can see everything happen. Okay, and then 5, enter, and no, that's incorrect. Now you can work that by hand if you like. Okay, or play around with it. I've done a variety of things. Like one thing I like to do sometimes, but during a test, you probably shouldn't. You should just use this method and move on because then the calculator did all the side calculations for you, all the work. Okay, what you did is you entered it as you saw it on your formula sheet. Okay, so it helps eliminate some errors. But let's just for grins go to auto. Okay, and now let's enter. All right, now that gives us a table of values. Would tell us if we had different areas. They could have stated 18, any area at all, 27, and come up with different questions here. When you're teaching, FYI, this is a good way to use the same image and create different versions and you know which numbers will work as an area. I know that, to get different heights. So I know if I have 18 as my area, then 4 would be my height. You can just arrow up and down and get different values with this different image. I do it all that time. That's how I have different versions of activities and tests. But anyway, a little tip for you. Okay, so let's look at number 4 now. If segments CB equals 3.35 and BE equals 1.5, what is the area of ABCD? That means the whole kite. Okay, now there are some properties of kites that we need to know, and they kind of helped us out. They did clue us in to some congruency. Okay, so that means that these smaller legs are congruent. So we have 1.5 here and 1.5 here, okay? Which is going to be convenient for us, okay? Because we need to find the area, right? Well, I see two triangles, right? Okay, so if I have 2 times base times height divided by 2, I have the area, okay? So I have this triangle here will be congruent to this triangle here. It's just a property of a kite, just to help us out, right? Okay. So if we find one of them, we can just multiply by 2 or add them, however you want to see it. We have something to work with. So what do we need to find? Well, we need to find this little distance here, CE, and we're going to call that X. If we find that, we'll have a base, okay? Then all we need is base times height divided by 2. Or think about it. All we really needed to say is base times height. Okay, however you want to look at it, okay? But for now, we need the Pythagorean theorem to get X. Okay, that's step 1. So let's do that. So go second mode, and now we need second radical, and we need 3.35 squared minus, okay, 1.5 squared. Double check my entries. So that is the hypotenuse squared minus, let's call it leg A, okay, to get us X or B. We could have called that B. I see ABC when I see right triangles. Now, you may be asking something. How can you know that it's safe to use the right triangle or the Pythagorean theorem? Well, that's a property of a kite. This piece is a right angle. That's what makes it a kite. Those 3 segments being congruent as well, it's saying that they're congruent. They wouldn't have to be necessarily, but this right triangle is a property. And other congruencies, you actually have 2 smaller triangles with that are congruent within the kite, and then you have 2 large congruent triangles making up the kite. So I'm just taking advantage of the properties of the kite in the first place. Okay, so now enter. All right, so that gives us something very close to 3. So I'm looking at my A, B, C, D options, and I'm saying I can use 3. So I'm going to say X is very close to 3. So that would give me CA equal, okay, from C to A. That will give me 3 plus 1.5 is 4.5. That's the distance CA. Well, because of that, I'm going to get rid of option A. Okay. Now, I need base times height divided by 2 and then times 2. Well, that means I need base times height. Okay. My height, I would say, is 1.5. So let's clear out our calculator. Well, our calculator is good. Let's clear it out so we can see it. Okay, so let me show you what I'm talking about. I'm saying 1.5 times our base is CA. So that's times 4.5. Press enter. 6 3/4, or it's roughly 6.75. Now, this is estimating. Remember, 3 was an estimate, but that's the options they gave me. Now, you're like, well, wait a minute. You have two triangles there. Let me show you why I did that. Technically, this is what we had. Okay. All right. We had base times height divided by 2. Well, let's talk about the yellow. Okay, here. Let me do this here. Okay. This would be our height, and this base all the way. Okay, let me put this back. I wanted all this in one color. We're estimating that that's 3. Okay, so from here to here, for one triangle, we're saying 4.5. Okay, so what do we have? We have base times height, so that is 1.5 times the 4.5. Now I'm going to divide that by 2. But that's just the yellow. But it's the same thing for the green. The green and the yellow are congruent, and because that's how we define a kite. That means we would either say 3.375 times 2 or plus 2. Okay? So let's say times 2. Or not plus 2, plus, or we'd have to take 2 of them and add them together. Sorry. Either way, we have 6.75. Wow, I said the wrong thing. Let me type in what I should have said. It would have been 3.375 plus 3.375. So there's 2 of them. So you can either multiply that value times 2 or add 2 of them together, however you want to do it. It's still the same thing. Okay, anyway, my point is there's more than one way to see it and do it, and D is a reasonable answer. Okay, let's move on to number 5. Number 5, in triangle RST, if the measure of angle R equals 72 degrees and the measure of angle S equals 29 degrees, which side is the longest? Which side is the shortest? Okay, well, this is a triangle. So we know that we need to take, well, to find, we need to, before I say all this, we are looking for the angle, the measure of angle T. Okay, so we know we need to take 180 minus 72 minus the 29, and that will give us 79 degrees for the measure of T. Now, I provided a blanket triangle so you could label it and see it. So this angle here looks like it's the largest because 79, 72, kind of close visually. So let's just label and call it good, right? But then we go across from that. This would be T, and that would be the longest, okay? All right, then looks like the shortest would be 29, which would be the smaller one. That's got to be S. And of course, this would be R. Okay, then across from S, that would be a small s. And across from R would be a small r, angle R, that is. Okay, so this would be the 72 degrees. So the thing is, R is neither the longest or the shortest. So anything with R can be marked out. That gets rid of A and B. So then we have C and D. Well, the longest is T because it is across. You look at the largest value of of an angle, you go straight across, and that would be always be the longest side. So that's T. So T is longest. And then, of course, when we look across from S, S is the smallest angle. So that would give us S being the shortest length. Okay, and that eliminates C. Okay, that's just kind of a question saying, do you know the properties? You know, they're not asking anything very difficult, but if you don't know the properties, then you wouldn't be able to get it correct. Okay, now let's look at 6. Using using the figure, using the figure to the right. Okay, I can see where they're going here. KL is 4, so let's label this 4 here. All right, great. HJ is 8. Okay, H to J. Okay, get that. And then it says HK is equal to KI. So we have some congruency. Okay. Now you may look at that and quickly think, oh, I see something. I know what that is. Because the question is, what statement is true regarding the figure? And you're going to look down at A, B, C, and say, oh, yeah, I think that that's, the property where we have congruency. And so that means we have parallel. No, it doesn't. Okay, here's the thing. Without this missing bit of information right here, without this bit right here showing congruency of these two. Okay, I changed colors to clarify. They're not stated as being congruent, it's missing. So you are missing information over here. And because of that, there is no guarantee that I, L, and L, J are congruent. And because that's missing, you cannot say that anything is parallel or equal. So you have absolutely zero guarantees. Okay. Now, if they had said parallel, they'd given you that information, yes, you can do a stretch. Or from if they'd given you the other congruencies where I have it marked in green, then you could have said we had a parallel situation. But because of that one missing bit, you can't make any conjectures. Therefore, D is the only right or correct assumption. You got to have all the info, and that's really important for this particular situation. Okay? All right. Now let's go up to number 7. If the height of the isosceles triangle is 1.5, what is the perimeter of the trapezoid? Okay, they've given us a very important piece of information. They have stated isosceles. Not only have they stated isosceles, they've given us this great congruency with the sides, as well as these two angles. That's extremely helpful because then we also know that our height from here to here and here to here, we can box this in, and that gives us this distance here as being 3. Okay? And we know that 7 minus 3 equals 4. And when we take that 4 and divide it in half, because there's two sides, okay, two little segments left, divide by 2, that tells me I have 2 here and 2 there. So that gives me 2 congruent triangles to figure some things out with, okay? And we know this height is what? 1.5. And that means I know this is 1.5. So where I have the marked green tick marks or hash marks of congruency, I can find that hypotenuse. Okay, so what do I need to do? I need to say second radical, okay, and I need 1.5 squared plus 2 squared, okay, because it's height. 1.5 is a height, and that guarantees us that we have this right angle here and here. It's just a nice consequence of the fact that everything's isosceles, okay? That we have congruency. And height gives us the fact that we have a height, we have to have a right angle. If we don't have a right angle, we don't have a height. We have a slant. And that's not what was given to us in the information. So that's very convenient. Okay, then press enter. So that tells me I have 2.5 on each side here. So I have everything I need. Okay. All right. So I have 7 all the way down here. I've got a lot of stuff written, so I'm just going to rewrite my 7. I have 7 is my whole base distance. Then I have 3, and I have a 2.5 and a 2.5. So those things I've circled, we add together. I'm clearing everything out. So 2.5 plus 2.5 plus the 3 plus the 7, and you probably have already added that in your head. It is 15, so C is verified. Okay, let's keep going. We need to go to number 8. Number 8, given the isosceles trapezoid below, what is the value of the diagonals? Okay, first we need to find out what x is. What is the value of x? Then we can finish our question. The property that we need to know in this situation is when we have or rather an isosceles triangle, we know the diagonals are equal. So let me present something to you. Okay, first, they're their own entity. So let's put them in parentheses. So I'm just doing this simply to maintain the order of operations. We can take either of those first, and if we subtract them, we're going to get 0, correct? Absolutely. So we are going to put this in the calculator. That one's all together. That's one diagonal minus the other diagonal equals 0. And the reason I'm using parentheses is because you could subtract the other way. We could say 3x minus 3 minus 2x plus 5. The issue is that this negative here in the center, because it's a minus, or I said negative subtraction, whatever you want to say, it actually becomes an understood -1, -1. Okay, so that will change whatever's behind it in parentheses. It's going to change the sign. Okay, so that being said, we really don't need the parentheses around the first diagonal, which for me was the one that was in pink. However you do it, make sure that you maintain your order of operations, okay? When you have a subtraction issue involved here, it needs to be distributed or find another method. Put it in your calculator correctly. That's my point. Okay, but that's all we're going to do here. So we need to push our table button. Okay, I already have mine in the calculator, but notice I don't have parentheses around the first diagonal, the 2x plus 5. Well, really wasn't necessary. You can do it if you wish, okay? All right, so now I will push enter. Okay, what am I looking for? Well, I'm looking for a situation where over on in the y, for y right here, I have 0. Okay, so I'm going to say 0, 1. I'm going to go with autos, and I'm going with steps of 1 because everything here in my ABCD in the first place is all whole numbers. I know I don't have a decimal issue. Okay, so I'm going to go whole numbers. I'm going to go with auto, enter, and I'm going to go down. See how things are decreasing? I'm going to arrow down because my y's are decreasing until I find 0. So I know that x equals 8. Okay? You can go through the manipulation if you wish, but I know that x equals 8. Well, this eliminates a for me. Okay? So then all I need to do is substitute 8 in my given for one of my diagonals. Okay, so I'm going to go second mode. Okay, and I'm going to say 2 parentheses 8, close my parentheses, plus 5. I get 21. Now let me check the other one. 3 parentheses 8, close my parentheses, minus 3. Okay, 21. That tells me that the actual value of each of the diagonals is 21. Now you can go through the motions of x plus 5. Okay, I'm jumping ahead of myself. Plus 5 equals 3x minus 3 because they're equal to each other, correct? And then we would have, let's subtract x, 2x from both sides. Okay, I'm going to do that there. Okay, so now, well, and while I'm at it, why don't I add 3 to both sides? Okay, I know I'm skipping teaching steps, but I think we all see what I'm up to here. Well, that's x equals 8. Okay, I don't know. It's up to you. I thought we got to it a little bit faster that way. Let's go to number 9. Given the isosceles triangle. Oh, they really love these isosceles triangles. Okay. They are a good thing to ask on a test because you have to know all the properties to get anything solid. Okay. All right. So, what is the value of the mid segment? They stated it is a mid segment, and that would be this x. First, they said it's isosceles, so you got all this great congruency everywhere. You have symmetry, congruency, very convenient. And the mixed segment says, oh, because of that, you can use that fact, this fact. So let's go second mode, and you need to set up your fraction. What that means is you can add the 9 and the 5 together. That's base 1 plus base 2, divide by 2, and you have the value of x, okay? So that's 5 plus 9, go down, divide by 2, and if you press the button, and we need 7, and that would be C. Now, there are other ways to see this. If you took this bottom piece here, let me do some highlighting here, took this section of this trapezoid, and this is also probably an activity that you've done or should be doing in the classroom when you talk about this special trapezoid. If you took this piece and you took this part, let's say, turn it over and matched it to this section, you would get one long strip that looked like this. Okay, right? And this distance of x, 7. Oh, I definitely did not know that would happen. That looks very strange. I mean, I just can't believe it came up. I didn't even know I did that. There we go. So you would have a situation where you would flip it over to where I know my drawing isn't accurate, but this bottom piece here would be the 7. Okay. And that would be the bottom here. Then you'd have 5 here. Then you would have 7 here and 9 here because it would flip around. That's just a little activity that you could do. And also helps you remember these things when you're taking a test and see it quickly. Okay, this is the last question in this video. Thank you for putting up with my extra yakking and pointers. I hope it helps you. And kudos to you for making it to the end of this long video. Okay. Thank you guys for liking and sharing and subscribing. You know what? Happy testing.